All right, hello again, everyone. Hope you're doing well. In the previous video, we worked on implementing our data access layer for our users table, which is over here. We implemented tests for that, and we've got all of that set up and working correctly. In this video, I want to walk you through getting the API server set up. And for a good chunk of this, it's going to be influenced by this article by Matt Ryer, who is pretty big in the Go community. He was one of the hosts on the Go Time podcast. And I'm not going to follow all of this to a T, but it's got a lot of good content in here, and I'll encourage you to take a look at it. But a lot of what I'm going to be a lot of the code I'm going to be writing is going to be influenced by this article. So I think there's a lot of good stuff in here. But yeah, to kick it off, I'd like to go ahead and start setting up packages for setting up the server itself. So first off, I'm going to create call this API server, and we'll just call this server.go. I'll create a struct that basically will hold all the dependencies that I need for the server's endpoints, and then I will hang methods off of the server struct that will be responsible for, basically that will be the handlers for each endpoint. That's something that kind of deviates from what he mentions in the article, but I sort of like doing it that way. Cool. So the first thing that's going to be part of the server itself is our config. We need that pretty much as a dependency for most things that we are working on in this project. So I'm going to go ahead and add that. We've already set that up. And I'm going to go ahead and create a constructor here. And since we're in the API server package, I'll just go ahead and call this new. And something that I like to do for this struct is just have like a start method or a run method. And that will basically initialize everything, shut down logic, things like that. So I'm going to go ahead and set that up. We can call this start. And I want to accept a context here so that I can handle shutdown logic as needed. So something to do here, I'd like to register a route. So for starting this up, I'm just going to have a ping route or something like that. Let's call this S API server. Let's do and obviously I'm not using a HTTP framework here in Go. I'm just going to use the standard library since I think it's sufficient for what we're doing here. And I think it's just good to be familiar with the standard library anyway, as much as possible. So especially with Go 1.22, they enhanced the routing capabilities quite a bit. So I actually think it's plenty sufficient for this type of project. So I'm starting off by creating a servmux, and I can register my routes using this. So for here, we'll just start off with ping, pass that route in, and we do want to create the server object using the HTTP packages server object. And here we need to provide the address. For now, I'm just going to hard code this, but we will go back and revisit this and make it configurable. And handler is going to be the mux that we created above. All right, so just like this should pretty much start up our server at a very basic level. And we'll add some more functionality to this, especially for shutdown logic and things like that. Another thing we need to do is actually create the main file that invokes this server. So let's go ahead and do that. Put everything in CMD. This will be package main. We'll have a main func here. And something I'm going to pull from the article that I just mentioned from Matt Ryer is he uses this concept of a run function. and he puts all of the logic in there, and then this can return an error itself, and then he can handle the error like so in the main function. So I kind of like doing this, and I think it's a cleaner way to do things. So I'll be following that pattern as well. So what we're going to do here is create our config. If error is not equal to nil, we'll return the error. And what we can do is create our server, which is API server.new. We'll pass in the config, and we'll do server.start. And we'll pass in a context. So I'll create the context up here. I like using signal.notify context because this is a nice way to cancel all of the resources if I do like a Control-C to cancel the process from the command line. So I like doing it this way. All right, we'll run that. That looks good. And for this, we'll also check the error. This is a blocking operation, but just in case something fails, we can handle it here. Okay, so now this should run our server, and we'll see what happens here. One thing I also want to do, it looks like it's running, but I also want to make sure that we're log dots. Okay, so server's running. Let's do curl http localhost 5000, and we'll do ping, and that returns pong. So this is running correctly. This looks good. The next thing I want to do is actually handle the shutdown logic. So in this article, he's got like a pretty good example here of how to handle this. But basically, he's running the listen and serve logic in a background function, and then handling the, in a background Go routine, and then also spinning up another Go routine, which will handle the shutdown logic. And then at the very end, he's got a wait group that's just making sure that shutdown logic Go routine completes successfully. So we're going to follow something like that. We'll just spin up a Go routine here. And we'll say if error is equal to server.listen and serve, error is not equal to nil, and error is not error server closed, then we will log slog dot, I'll do error. Okay, and one thing I want to do before I start getting too deep into this is go ahead and set up a logger for this server, and I'll pass it in as a dependency. So let's do this. It'll be slog.logger, and I want to do the logging in like a JSON, a structured JSON format. So what I will do is go back here, create the logger, and say slog.new JSON handler. This will be os.standardout. Okay, so what we're doing is creating the JSON handler, writing it to standard out, creating the logger from that JSON handler, and then we'll pass that as a dependency here. This should be a logger. Okay, so now I'll just do s.logger. Whoops, let's do this. Logger is equal to log.logger. I'm also going to make this lowercase. This doesn't need to be public. Lowercase. Okay. Now we've got the logger as a dependency on the API server. I'm using that here. All right, and let's do that right here. And let's just pass in the port here. Port will be 5000. And something I want to do is actually parameterize this and make it accessible via our config. So I'm actually going to go ahead and do that. Server port, make it 5000. Export API server host is equal to localhost. And I will go ahead and add those to our config. Server port string env API server port. Delete this default. Okay, now we've got both of those. In our address field here, we can say net.join host port, and we can just pass in the config API server host and port, and then we can say listening on port over here s.config.api server port. Okay, so I'm just going to return nil here, and then we need to spin up another Go routine to handle the shutdown logic. So go func what we're going to do is create a wait group. And we'll do wait group.add. I'm sorry, wait group.add. And then we'll mark it done so that it decrements this value that we added when this Go routine completes. We're going to wait for the context provided to the start method to be complete. This means that something was canceled. And at this point, we want to shut down our server. And basically what this means is we're going to not accept any new requests, and it'll wait for some time so that existing requests that are in flight can complete. So we will shut down the server. I'm going to create a new context for this. Shut down context and a cancel. We'll give it maybe 10 seconds to shut down. So if you look, shutdown gracefully shuts down the server without interrupting any active connections. Shutdown works by first closing all open listeners, then closing all idle connections, then waiting indefinitely for connections to return to idle and then shut down. If the provided context expires before the shutdown is complete, shutdown returns the context's error. Otherwise, it returns any error returned from closing the server's underlying listeners. Okay, so we can say log this. API server failed to shut down, pass the error. I do want to look at this. This is very similar to what he has here. This is where I'm referencing it. Yep, all we have to do at the end is wait for the Go routine to be complete using the wait group. So wait group, wait. Okay, so now what I want to do is start the server, cancel it. See, this is not canceling at this time, but if I restart the server, so it's now running. The port is not active though. So what I need to do is actually, you can see that this port here is not being printed out, and that's because our environment variables that we just added for API server port and API server host are not accessible yet, so we need to refresh those. So we've refreshed the environment variables using the dir env allow command, and that has now made these accessible. So now when we run the server, it's running on the port specified through the config. And I should be able to Control C to shut down the server. And that worked. Okay, so that's great. Now we can just curl it. Great, so now it's giving us the Pong response. One thing I always like to have is a logger middleware so I can log each HTTP request that's coming through. And then we're also going to have a middleware for handling our API token checks, which we won't quite implement that one yet, but we still want to get our middleware set up. So what I want to do is, let's see, in this API server package, let's create a Go file for middleware. And then what we're going to do is create a constructor that returns an HTTP handler implementation. And I'm sorry, it's going to return a function that returns an HTTP handler. Basically what we'll have is this middleware, and it's also going to accept the logger that we've created for our server. We're wrapping this in handler func like this because this type implements HTTP handler, which is just the serve HTTP method. Okay, so from here, I want to just log out the request and invoke the next middleware. So one thing we need to do here is call the serve HTTP method of the next handler. And what we'll do is just implement our logging here. So say method is get, path is the URL path provided from the request. So we're just logging basic request info here. And what we can do is go to our server and wrap the mux. And what we can do is just wrap this mux in this middleware. Since this mux itself implements HTTP.handler. So now we can rerun our server. I'm going to cancel it. And we should be able to see requests being logged. So let's go ahead and curl it again. Ping, pong. Okay, so cool. HTTP request, we got the method and the path here. So that looks good. And I may actually simplify this a little bit and just call this like path and then do r.method and do something like that. This might be a little bit easier to look at. Cool, that looks decent to me. So we'll keep that. And what we can also do is add an authentication middleware that basically verifies that our token is valid, and then provides that user information, user principal information on the context itself, so we can access that at various points in the request lifecycle. But what we're going to do is we're going to hold off on implementing that middleware for now because we don't have any of the JSON Web Token logic implemented. So we'll save that for a later time. For now, I want to go ahead and implement the signup handler. So what this will do is create a new user in our system using the data access layer helpers that we created in the previous video. So I want to go ahead and get started on that. So what I'm going to do here is create a new Go file called handler. And I'm going to put most of the logic in here for our server endpoints. So this will be API server, let's say signup handler. Okay, so for the signup handler, what we're actually going to need is a username and password in order to sign up a new user. So let's create a new type, sign up request. We're going to have the email, which is a string, and the password, which is also a string, and we're going to specify the JSON fields like this. And what we're going to do is decode this so that we can have that information populated into the struct. And this can return an error, so we're just going to go ahead and check that. And we'll say bad request and return for now if this is invalid. Let's go ahead and check and make sure that this is valid. One thing I'm going to do here is just go ahead and add a method to this type so that I can validate it itself. Okay, so just like that, we can validate this. I'm going to go ahead and say if error. We'll do the same thing here. Return. And now at this point, we're going to need access to our user data access layer, so our user store. We do not have this as a dependency on the server yet, but we can go ahead and add that. And to make things simpler, in the future, I'm going to create a generic store type that basically encapsulates all the other types of stores. So basically all my tables will be accessible from this store type. So let's do users. Okay, so now we've got a sort of wrapper store object, and I'll just provide this directly to the API server. This is just a convenience type of thing so that we don't have to add each table to several different places. Okay, so I'm going to go ahead and add that here, store. Okay, so now I can reference the user store. And we'll go ahead and create a user. We'll pass in the request context, the request's email and password. Actually, we need to provide the user here. One thing I want to also do here is check if the user is already registered using that email. We can do that by quickly querying for the user by that email. So we'll do by email, r.context, let's say rec.email. Okay. The error is not equal to nil. And then here we can just say if existing user is not equal to nil, we'll make this a bad request. Actually, we can use status conflict here. That's fine. And of course, we want to return and at this point we can just return a success message saying that the user has been signed up successfully, and I don't even think we need to use this user object here. Okay, so we can just say write header status created, this is a 201 w.write, let's do json.encode .encode. Okay, here's a point where I want to start making some helper structs for handling my responses. So one thing I'm going to do here is just have a generic API response that can either contain some data that I want to return from the API or a message. So sometimes if there's a bad request or something, I want to show a message that may be visible to the user. We can do that here. So what I'm going to have is just data, which is going to be of type T. It's going to be a pointer because we may not have data in some scenarios. And then I want to have message, which is a string, and we'll omit empty if it's not provided. So what I want to do here is provide API response. I want to provide an empty struct, if that works. Yeah, that works. And we'll just say we'll just say successfully signed up user. Okay. If error is not equal to nil, then we can do something like this and return. Okay, so what we can do is go ahead and try out this endpoint. I want to make sure that we register this in our routes. Let's say auth, sign up. Sign up handler, cool. So now we can hit this endpoint with a post request. Actually, we need to make sure we signal that here. It's a post, and this only accepts GET. One thing I forgot about Go 1.22 is that you can provide the method here. Cool, so now we can test this out. So I'm gonna restart the server. Oops, let's make sure that we have this. We need to provide the user store. Okay, so we're good there. Let's go ahead and run this again. All right, API server is running. We're gonna do HTTP, let's do curl -x post -d. We'll pass in JSON with username, or sorry, email. And then password. Okay. And we'll go ahead and pipe this into JQ so that this is a bit easier to read. Okay, we've got an error here. JQ parse invalid. All right, so we did see the request come through. Let me do this again. Failed to fetch. No rows in the result set. I forgot this one thing. This is expected. If there's a row that's not found in the database, it will return a SQL error, no rows. So we need to go ahead and handle that scenario here. Okay, so we need to say and errors.is error SQL.error no rows. I want to check if it's not that. Then we'll just return. Otherwise, this should work. Okay. So if for some reason it's not error no rows, we will return a internal server error. So I'm going to restart the server. Run that. Cool. I'm now going to create a different user. Actually, I'm going to do the same user and pipe it into JQ. Okay, that's fine. Pipe that into JQ. Now we've got our response data here. And one thing I want to do is, I guess I can do omit empty. I'll try that again. Restart the server. Okay, so that works. The data column is omitted. Okay, that looks good. Okay, so obviously this is all fine, returning these errors like this. But I want to take a slightly different approach, which is inspired by a video I saw by Anthony GG, where he wraps each of his handlers, which allows him to return errors. What I'm going to do is add some helpers here. So what I'm going to do is create handler, which accepts a function that returns an error, and then returns the actual HTTP handler func, which I can just write as this handler func. Yep, that looks good. So what we can do here is just return that. Let's say if error is not equal to nil. So what we can do is return a HTTP handler func, and then within that handler func, we directly invoke the handler func which returns an error. And then based on the error that's returned, we can either return an appropriate status code, we can log the error that occurred, or we can send a message that's visible to the user. Okay, so what I'm actually going to do here is we're invoking the function provided, which is a handler func that returns an error. So I'm actually going to implement a custom error that also has the HTTP status that I want to return. And it's going to implement the error interface. Okay. So what I want to do here is just check if this error is an instance of this type. So I can say if, okay, error with status, then I'm going to capture the status code from that error. So what I want to do is have sort of a default status, which is going to be internal server error, a default message, which is so what I'm basically setting up here is if I'm getting a HTTP status of bad request, I want to surface some information to the user. So I'm going to use the error message returned directly from this type. And otherwise, I'm just going to default it to internal server error. So if for some reason I'm not returning this type of status, it'll just default to internal server error. And I'm also going to make sure that the status text is defaulted here as well. The other thing I want to do in here is make sure I'm logging information from the error. So I'm going to go ahead and do slog.error executing handler. We'll say error is equal to error. We'll say status and message if it's available. Okay, so that's good. And the other thing I want to do in here is write the status and then also write JSON response that surfaces the message to the client. I'll just do an empty struct here. Okay, so now I'm just passing the message directly. If error not equal to nil. So if something happens where we can't do this, so if something happens where we, for some reason can't encode this response, I'll just log that here. And I think this looks good. So now what I want to do is go back and refactor the code that I just had for signing up the user and wrap it in this handler here. So let's go back to that. And I want this to be sign up handler, which actually returns an HTTP handler func. Okay, I'm going to return all that. I don't know if I actually need to do that. Okay. So I don't actually need these. And all I have to do is wrap it in that handler. Okay, so now what I'm actually going to do is actually return an error to this function. Okay, That looks good. Make sure I'm returning that. Okay, the status I want to return here is http.badRequest and say fump.error invalid request. So now I can just return this directly. It's a lot cleaner. Same thing here. I'm just going to return bad request, and I'll just return the error message directly from here. So that's good. Actually, we can do this. Error F failed to invalid request. Same thing here. I'll just return new error with status. Let's just say email already registered. And this is a different status code, but I actually want to make sure that this handles that as well. So if it's bad request or status equals status conflict, I will set that as the error message. All right, we'll just return the good old internal server error here. And same thing here, we'll just return internal server error and return nil at the bottom, since we are anticipating a return value. Okay, so that's good. One other thing I want to do to clean this up is make use of a pattern that Matt Ryer suggests in his article, which is using encode and decode functions. This is a lot of boilerplatey type of code that is repeated often, so we can simplify this quite a bit and just clean this up. So I'm going to go ahead and add those helpers and refactor this code to use those. Okay, so I'm going to create an encode function that is generic, and it'll accept the type that we're encoding, which is API response of type T. That's the data type, a status, and the response writer. What we're going to do is go ahead and set the content type, which is application JSON. I want to go ahead and write the status that we've provided, and then do the same logic that we've done in other parts of the code base, where we just call new encoder.encode. Okay. And what we're going to have to do here is just slog this error. Actually, what we can do is just return this, since we do this already. So return from.errorf encoding response, return nil. Actually, I'm going to make one modification to this. I'm not going to use API response here. I'll just make sure it says T, and then I can just invoke this here. Okay, so at this point, we can now use the encode function like this. We can simply pass in some type that we want it to marshal into, the status and the response writer. And if it fails, we can just return an error like usual. Likewise, I'd want to create a decode helper that basically does most of this logic for us. For anything that takes in a post request body, I'd like to make sure that it implements this validate method. and we can handle all of this logic within the decode helper. So let's go ahead and implement that as well. So what we have here is a generic method. We can marshal the JSON into this type and return it directly, or we can return an error if it's not successful. One additional restriction I want to make is that this should implement the validate method. So we implemented this on this request body, the sign up request body here. I'd like to make sure that there's an interface here that we can use to ensure that we can invoke validation on each request. So I'm going to go up here. Let's just have a validator, and we'll implement validate, which will take in an error. Oh, sorry, which will return an error. Okay, this will take in a validator, and we are going to decode the request body. And we'll put that into the new type we have here. Okay. So now I'm going to comment this out, and I'm just going to say if error decode, this type will be signup request. I'll pass in the request. Check the error directly. What do we have here? Oops. We're going to have a bad request here, status bad request, and the error that was returned from the decode helper. So as you can see, this is a pretty clean way to unmarshal and validate the requests that are incoming. So we can delete all of this extra code here, and this has just reduced a lot of boilerplate. And the other thing we need to do here is just turn this into a function that is returning this wrapped handler, since we've completely changed the way our error handling is working. We want to make sure that we're actually converting it to a handler func. And so that's why we're just calling this as a function now. Okay. So let's go ahead and test our server again and make sure everything's working. And I'm going to do 4 here. All right, successfully signed up user. Okay, and so I think this is probably a good stopping point. I think in the next video, we want to start diving into JWT auth and getting the rest of that implemented. Probably diving into our auth middleware and things like that. So I'll see you guys in the next video. Take care.